everyone. Welcome to Project Stay 2025. My name is Prerna Janeja, and I'll be the host for this session. Thank you, everyone who is here in person and who has joined us over Zoom. Thank you for being here to support our students. We have three amazing presentations lined up. So each team is going to present for 15 minutes, followed by 5 minutes for Q&A. And let's just get started without any delay. So our first team is already here. They are going to present their project titled AR Immersive Footprints, App and Mural. And this project was sponsored by Revere XR. Take the stage.
Perfect, thank you. Hello everyone. My name is Brian. This is Bruce. That's Sally, Shane, and Carlos. And hello? Working? Okay. Yeah, hello everyone. So this is Bruce, Sally, Shane, and Carlos, and my name is Brian, and we're working with Revere XR for our capstone project. We are... so our sponsor is Yolanda Barton, founder and CEO of Revere XR. She's been amazing throughout this entire thing. We have Professor Cuneo as our advisor, who unfortunately is not here with us today because of COVID. So we're working to create an app, an AR app to tell people about the story of Seattle.
So to understand why this project matters, let's picture Seattle Central District today. Rapid gentrification is erasing the neighborhood's Black heritage. Also, traditional history tools might be costly, town-bound, and inaccessible for many visitors. Yet the tool to reverse that loss sit in our pockets. Augmented reality layer digital stories onto the real world without the expense or exclusivity of VR headsets. But bring art and history back into the public realm. Our opportunity is clear. Could you go to the next slide? Thank you. Our opportunity is clear. Deliver a self-guided on-demand tours that make the mirror speak, move, and teach whenever someone has 5 spare minutes. By doing so, we preserve memory, spark curiosity, and reconnect the community with its roots. With the big picture need, let's meet the artists whose newest work that anchor our experience. On screen, you are looking at Melvin Freeman, aka Flyblind Guy, and his 2020 public artwork, We Are Water, stretching along 23rd Avenue South beside the Northwest African American Museum. The piece spells out Central District while a young girl with a hose spraying water that flow through letters. Inside each letters are everyday photos of the neighborhood, people, shop, and landmark from both past and present. The water was chosen as a central motif because, like the community itself, it flows across boundaries, connect us to history, place, and freedom, turning the mirror into a single, unbroken current of shared memory. With the mirror providing our narrative spine, let's see how we turn it into an immersive app you can launch in 3 seconds. Our vision is to build a seamless bridge between the mirror and the metaverse, an experience where the artwork will literally steps off the screen and greets you. Our concrete goal is to ship a lightweight mobile app that anyone can download. The mirror will load in under 3 seconds and erase itself when you walk away. Each character is anchored to precise GPS coordinate. While the audio narration plays, there's an on-screen infographic lets the visitor read along. This provides different learning styles and accessibility needs. Now you know the what and why. I will hand it over to Shane, who will talk about our final deliverable and the technique we use.
Hello, I'm Shane, and like Bruce said, I'm going to be going over some of our app features, and some of these slides are going to be a bit repetitive because we're just showing the same information in different ways. And Bruce covered our final deliverable, so would you please move to the next slide, please? So, architecture and key technology. We did our main work in Unity using the SDK for Niantic's Lightship and the AR Foundation, which provided the AR features that we have in the app. And the great thing about Unity is that it is platform agnostic. So we've been able to deploy apps on both iOS and Android. Now, disclaimer: the Android app is not experienced, not polished, because I'm the only Android user on my team, and so it doesn't quite look right, but it is still technically possible, and we could actually, in theory, make a build profile for the Android phones. You have to make profiles for every single device because different screen sizes have different display dimensions and all that boring technical stuff. And the version control software that we use, just like everyone else pretty much, is GitHub. And it's made it very nice because at the very beginning of the year, or of our project, I should say, of the school year, we were trading a 3 gigabyte app in a zip file on Teams, which is very slow and very annoying and tedious. So GitHub thankfully allows us to check the differentials in our app and make sure that we're not actually having to reinstall like the basics of Unity. If we have Unity on your computer, then you have the project files that are the only things changing. So that way we can just base it off the project file changes. And I already covered the agnostic thing. Yes. Okay. Please, next slide. System layout is this expertly rendered graphic. Essentially just goes over what I basically said. So we do our version control system like GitHub. We do our editing in Visual Studio, really whatever app you want to use, and it changes our Unity game engine test files. Not on there is Blender and our other asset creation things. It also feeds into our Unity game engine, which eventually gets pushed out to the Android and Apple phone. And it's been a very simple process, thankfully, due to large effort and a lot of the open source software that we use. We try to make it as open source as possible, or we try and use as many open source software as possible, just because it's, it's out there, it's documented, and it's got a really well built community behind it. Next slide, please. About the same thing. This is sort of the general flow of our diagram for how the apps work and interact. And nothing too crazy here. We don't actually use GPS. We've actually been basing it off of an image. It's not too hard to switch over, but for purposes of demonstration that we'll get into later, we're basing it off a QR code. But yeah, so you basically have the app look at the scene and grab the image, and then you can display the overlay of the 3D assets that we created. And those are our objects. The objects are tied to the location, which in this case is the QR code, and it just feeds in there. Next slide, please. And the UX design wireframe this is actually expertly rendered by our Sally over here. This just goes over how the app looks like, how each page is supposed to transition to a next page. And there's not really pages on the app, but it's sort of kind of how it's supposed to look, the kind of feel, the general trend of things. And we wanted to kind of maintain accessibility, even though this is a phone app. We wanted to maintain the fact that this is a phone screen that you're looking at ostensibly outside. It might be hard to see. And originally we were thinking about doing a project in one of the international districts murals, and that would have been like an additional concern of like walking in the street with your phone. So don't do anything stupid with your phone that you wouldn't do without your phone, essentially. But yeah, this is kind of goes over how the general app plays out. Next frame, please. And then now we've got our demonstration.
Awesome. Thank you, Shane. So while we get set up for the demo, I do want to preface this morning, if any of you came to our booth and saw us like hunched over in the corner, that's because we did a test this morning and a random magenta object appeared in the back of our AR app, and we don't know how to fix that yet. So Yolanda, next week when you get the final version, that won't be there. And for today, just pretend that's not there. All right, so we can go ahead and get into the demo. So hello, everyone. Yes, we can see you all. So our app is triggered with an anchor. So before the anchor is scanned, which is the QR code, nothing will be seen in the frame. It will just look like a regular camera. Then we go ahead and we scan this anchor, and here we have our final mural and design. So I'm going to kind of go through a couple of the things that we're seeing here. So first, let's talk about the anchor itself. The anchor was made, as Shane mentioned, with Niantic and AR Foundation SDKs. This basically allows for two things. One is persistent tracking, which is basically the anchor itself. And then the other thing is camera see-through or pass-through, which basically means that we can still see the rest of the world through the camera, but also see the objects that we made. So that's the anchor. Then one thing that I really want to talk about that we're very proud of is the actual letters We did scale them down for the purposes of this demo because this mural is huge. But yeah, these letters are an exact replica of how they look at the mural. The way we did that is we had Shane go out there and take high quality photos with his camera. With those photos, we used the shape, we put the shape of it into Blender and you put a plane over it. So then we got like the exact shape of the text, because as you can see, this isn't like some just like Helvetica font or something. It's like some custom font. So we did that to get the exact shape. We extruded it to make it 3D and added a red border. And then we used UV wrapping, which is basically where you map a specific point on an image to a specific point on a plane. So that way, our like images on here, they are actually pretty like high quality, except the magenta thing is kind of blocking it. But you can actually see like the faces of the people in the pictures in the actual mural, which was very important to us. So now we'll get into the waves. So the waves, they all originate from one point, which is pretty awesome. And it was something that we kind of struggled with for a bit. But it was really important for us that they all start at one point and kind of shoot out in different directions, because the actual mural is a hose and like water is spraying out of the hose. So it wouldn't really make sense for the water to just be like coming straight at you from all angles. So yeah, that's pretty awesome. We just used an origin point in Unity to do that. It also has a transparent background, which just makes it look a little bit more realistic. And the cool thing about this is we always knew we wanted a transparent background, but towards like the end of winter quarter, we had a pre-made animation that we were using, and so we had to use alpha transparency and things like that. But these waves are being generated live, so it was kind of nice to just be able to use Unity's built-in features to make the background transparent without having to worry about all that. So now let's get into what the app actually does. So we can go ahead and press on the first letter. I'm just going to press on the C, and it takes you to a new scene. The first C just has a welcome screen with instructions on how to use the app. In general, it's a very simple app. You just click on each letter to kind of gain some knowledge about the history of Central District, and then you click again on the screen to exit out of the app. So that's what this first screen says. So we're going to go back and then rescan this. All right, so that's what the first letter does. Let's go through a couple other letters. Let's go to this E. Here we have basically a little bit of an introduction to Melvin, because this is supposed to be a public experience, and obviously people aren't going to know who Melvin is when they first get there. So this is just talking a little bit about how he grew up and what attracted him to making art, things like that. And then just kind of tells a little bit about the life story of Melvin, including a wonderful picture of him. So yeah, that's one type of content that we have. We have two other content types in our app. So all of these letters present content in different ways. Some of them are just static images, some of them have audio clips along with them, and then some of them have videos. We're just going to demo the audio clips as well. So I think the T had an audio clip.
I wanted to show that history. And what I did was,
That's not a
you
good
know,
idea.
Central District is 15
But
letters.
there is audio
so
playing out
in a
of
way,
the phone
starting with the
that
C,
users can
I took
enjoy,
all of
which
the
isn't
older pictures
great for the
and I
demo.
just kind of
But yeah.
started with the
So I think that's everything for the demo. We can pass it off to Carlos for the
Thank you, thank you. All right. So just a little my slide of the presentation. So I'll be talking. So our next slide will be the major lessons, because let's say as the progress of our project developed, we ourselves developed as well and learned some important lessons on how these types of projects are worked on. Not only technical skills, but the most important thing that might sound obvious is that the importance of clear and consistent communication with us as a team. Now, at first you might think, yeah, that's obvious, but at first it was a little bit difficult. There was hindrance of coordinating meetings and aligning our tasks. But over time, we were able to progress systems of check-ins, regular meetings, because even with all the technology of today, when people are together, they're just more effective, as we have shown. And as well as aligning with centralized documenting, it helped a lot. And also our technical skills grew up immensely because even though all of us are experienced on coding, this was a whole new field with us of Unity, AR development, and mobile development. But like Shane has mentioned, Unity helps a lot with the works. And last but not least, unit testing. Unit testing is like, we thought it would be the final step, but no, it's the guide to the development because it is what helps us do what able to tell what will be the user experience to bring the most immersive experience and to have a little prototype to show our sponsors how far we are in the work. So what now? So now we're just going to submit this our product to GitHub, where our sponsors will take it. And what we are hoping for is not only for this to release soon, but also that hopefully our app model can expand to not just one artist, but also feature multiple artists in Seattle to able to share their works and experience. Because I think this type of technology is the best emerging both art and technology to be able to preserve the art of the person while also maintaining their integrity, especially in today's age with the dilemma of AI art, if it's true art. So, and I think this method is the best of both worlds to benefit both. And that's not. All right. Well, yeah, that's it. So I would like to thank Yolanda, our sponsor, Melvin, the artist, the man himself who made everything, who gave us all the info, and Braxton Kuno himself, the advisor who helped us all the way through, who unfortunately could not be here, but is hopefully watching us through Zoom, and anyone else who supported us along the way. And yeah, thank you. And any questions?
Not everyone all at once.
How did it feel to be working with emerging technology that's really relevant today? You can take that.
So, like Carlos said, most of us haven't really done anything VR or AR or 3D. I had a little bit of personally Blender experience coming into this, but like I've never done AR stuff. I speak for the team when I say we've never done AR stuff. It's very cool. It is genuinely very cool. Like you saw during the demo, the tech is still a little bit kind of iffy in some places, but it's a novel experience, and we had a good time learning about it. I think it pretty much covers. It was fun.
I have my personal question for you. Why you choose Unity? Because we have another engines that you can use for this project. Why Unity?
You want that?
I think we chose Unity for a couple of different reasons. I think one of the main reasons is just because of how prominent it is in AR building tools. So there was a lot of resources out there for us. And for us, when we started, one really big thing was we were looking ahead at this project and thinking, we don't have any experience in any of this. So we really tried to pick something that was going to kind of make our life as easy as possible just by having as many resources available. And then also, yeah, we got a lot of recommendations for good tools to use in Unity, like specifically the AR Foundation SDK, which was really helpful for our specific project.
Yes. No, okay. I don't know if I'm gonna do this for like a job personally, but it was genuinely a very cool experience. Like, the benefit of working on this app is having the actual mural like visible in AR space. It was kind of like not like in a whole new thing or whatever, but it was kind of breathtaking to see when those letters first populated and stayed in space on that anchor. It's kind of crazy. Like you've seen that stuff. You play Pokemon Go. It's nothing novel, but doing it yourself is kind of like a fulfilling experience in its own right, I'd say. You got something to say?
Yeah, I would say yes. I was excited in the XR. In fact, this is why I picked when we were deciding on the price. I picked this because I wanted to focus on a field, and I think XR is a really prominent and still promising field that still has not reached its full potential. I know it, everyone nowadays it's with AI, but still think XR has its place in the world. And this just bring me a good idea of how it works, and I loved it. It was brand new, difficult, but it's a field that if I had a chance to work at again, I would 100% do it.
One small question. Anyone? Okay, then let's give a round of applause for the team. Amazing demo. Okay, let's invite our second team. Okay, so they are going to present a project titled Revolutionizing Soccer Viewing Experience at Seattle University, and it's sponsored by our very own Seattle University Information Technology.
Yeah. I'm younger. Oh, yeah. So I have to set.
All right, everybody, welcome. Good afternoon, and I'm glad you could join us today. We are Team CS 2515, and this is the automated ball tracking system. My name's Bridge, and I'm joined here by my teammates, Haite, Kim, and Unsung. So to start us off, I'm going to hand us off to Kim, and I'll be back speaking later.
Yeah, so first of all, we want to express our acknowledgement to organizations and individuals that support us throughout the project. So first of all, we want to thank T-Mobile for their sponsorships and also for the 5G network that they provide. Second of all, I want to thank SUIT, especially Travis Leo, for their support and hardware and also deployment. Thirdly, I want to thank to faculty advisor, our Professor Zili, for the technical advice. And also thanks for the Seattle U Capstone programs for their guidance and support. Yeah, so for our goals and impacts, we had three main goals. The first is that to achieve low latency and high accuracy ball tracking. Our second goal is to enhance the fans' viewing experience. And our third goal is to deliver a live broadcast ASU soccer games with overlays and minimum delays. For our impact, we will be the Seattle Youth first 5G powered live sports streaming system. And this will also support Seattle Youth transition to the West Coast Conference. And it provides a scalable and reusable system for future development. For our MVP, we focus on providing real-time, accurate ball tracking throughout the match. We also integrate a live feed with 4 global cameras, and we leverage YOLO V7 for object detections and T-Mobile 5G network for transmissions. We stream directly to Twitch with real-time overlays, and it's done on a local host that runs the entire system. For the fans, this means a continuous and dynamic soccer experience with no missed moments, and is with optimized angle to maintain uninterrupted coverage. For our software use, we use 4 GoPro Hero 9 cameras that we place at different positions in the soccer fields for multiple camera feeds. We also use Inseego FX3100 modem for T-Mobile 5G network. And we use an Alien laptop to run and test our system. For the software stack, we use YOLO V7 for ball detections. We use OpenCV and Fmpeg for video manipulations. And for our backend, we use Python and leverage multi-threading. We use RTMP server for live broadcastings and send the stream directly to Twitch for the friend to view. Next, I will hand over to Unsen to continue our presentation.
Yeah, so now I'll be going over some of the challenges that we faced throughout our development. So first we have the stream instability. This was caused mainly by mismatch between frame processing and frame reading. So we use buffer queue and threaded reads to decouple reading from processing to minimize any memory overuse. And we also had a synchronizing issue, synchronizing frames across camera. We had an issue with that. We used time-based decision and dwell time to solve that problem. And then we had GPU inference delay. So we use GPU for YOLO algorithm for tracking the ball, soccer ball. And we had some delays in that. So we used half precision and eager compile to solve that problem. And we also had a stream overlay flickering, where the overlay was flickering when the streaming was happening. So we used PIL rendered UI, which is a Python image library to implement the overlay and then have a fixed position so that it is in a fixed position regardless of the stream size or stream resolution. And I'll be briefly going over the key features. So we have the real-time ball tracking, which was achieved by the YOLO V7 model. And we have multi-camera video stitching, which integrates footage from fixed cameras for seamless streaming. And we implemented the overlay, like I talked about, which displays the scores, team names, and logos. And we have automated camera switching, which switches between cameras to provide the viewer with the best camera angle. And we have 5G based low latency streaming, which was done using the T-Mobile's 5G high speed real-time video transmission. So I'll be going over the camera switching logic here. So we have in this diagram, we have the video frame, which is 1080 by 1920. And we split up the video frame into 6x3 grid. And then in this diagram, we have the camera 1 as active camera. And from the YOLO V7 model, when it tracks the soccer ball, it creates a bounding box. And the center point of that bounding box will determine which grid the soccer ball is in. So right here, if the soccer ball is in any of these 5 grids, which are called dead zones, we will switch to camera 2. And if it goes into this grid, it's a dead zone for camera 4, so it will switch to camera 4. And it will do the same if the active camera is different. So if we have camera 2 as active, we have if the ball goes into column 0, which is right here, it will switch to camera 3. And then if it's in the other 5, it will switch back to camera 1. And we also use 2-second threshold to prevent any flickering and ensure stable view. And some of the key takeaways from our learning. So we deepened our understanding of the Python threading and queue for managing the video streams. And then we also leveraged the hardware acceleration efficiently by using the GPU based inference for the YOLO V7 and using the FFmpeg for streaming. And then we also learned about the complexity of the real-time synchronization. And then lastly, we learned how important our documentation is and keeping all tasks evenly throughout our team members, then delivering our goals. Now, I will be talking about the software architecture.
this diagram shows how the entire process flows. So it starts with Google cameras recording the Psyche game. And then the video data is sent to the RTP server for processing. And then our video switching system evaluates the different camera feeds to select the best camera angle for a better viewer experience. The selected video feed is sent to Twitch for live streaming. This process ends when the live streaming concludes. Right, and this diagram shows how we build, test, and check our video streaming system. So we write and save our code using GitHub, and 4 GoPro cameras can record and send the video to the RTP server. The video data will be processed by the YOLO V7. YOLO V7 is a deep learning model that can quickly find objects in pictures and videos. YOLO V7 detects a soccer ball in the video, and based on where the ball is located, our video switching system evaluates different camera feeds and chooses the best camera angle. And the selected video feed is changed into the right format and sent to Twitch for live streaming. At the end of streaming, we store our video footage in Amazon S3 for future use. In the future, we could use cloud services like AWS. Currently, we are using a local setup because when we test this streaming video to the RTP server hosted on Amazon EC2 instance, the latency was slightly bigger compared to our local setup. However, in the future, if we need to do more complex processing which requires much more computing power, or if we want to have high availability, which means the system is always up and running, we could use AWS to help with that. So here is the cloud design that we have right now. First, on EC2 instance, we install Nginx with RTP module so that it can receive live video from GoPro cameras. So for GoPro cameras, gonna send live video to the public IP address of an EC2 instance. And inside of EC2 instance, we run our script to read the video, processes it, and send the best camera feed to Twitch for live streaming. This way, AWS can help when our local setup can't handle the work. Also, we used AWS cost calculator to estimate how much this cloud design cost. If we use the general purpose medium size of EC2 instance, 15 hours, and 30 gigabytes of Amazon S3 per month, the monthly cost will be around $3.5, which shows even if we use AWS, it is still very low cost and affordable, right? And Bridge is gonna take over.
All right, let's talk a little bit about the core algorithm used here. So we use the YOLO V7 model, which is, the beauty of it is it's a pre-trained model. You know, I'm not sitting down and going frame by frame, making a box around a soccer ball so that I can train it. And if I give it a video, it's gonna know how to follow that. So those pre-trained weights are loaded at runtime. And after that, each frame, as it's getting ingested, it is resized, normalized, and sent to the model for tracking. To speed up this process and make it more optimized, we use torch.compile, which just compiles the model into something smaller and efficient. And we also use FP16 inference. Actually, we use AMP, which is automated mixed precision, which is a mixture of both FP16 floating point and FP32, which is really a trade-off between precision for a little bit more processing speed and memory efficiency. So next up, I'm going to talk about the code optimizations. I did mention a few of them already, but we use a multi-threaded architecture. It's lovely, you know, parallel processing. We have one frame reading thread that ingests the RTMP stream, and we have another frame processing thread that gets it ready with the YOLO model and goes ahead and encodes it with FFmpeg so that we can get it streaming for Twitch. After that, we have hardware accelerated encoding, as I just mentioned, for the Twitch streaming, because there's a difference between normal video formats and what we need, which is regulations to be streamed online with an RTMP endpoint. We minimize the latency with a good pipeline and buffered queues. We have 4 cameras running, and we don't have enough computing power really to get everything going at the same time. We have one active camera that reads all the frames, and the other cameras take maybe every 10th frame, or they work at a lower frequency until they're switched. And after that, the overlay, it is drawn using the Python image library. And the nice part about this is that it's cached so that it's not rewritten over each frame. Otherwise, that would just, make it very slow. So I'm going to go ahead and show you a demo. This is going to show a little iterative process of how we first started out. It's going to be a little slow at first, but you'll see how it maximizes out towards the end. So that's super slow. It's going to be a little laggy and doesn't seem that impressive at the start. But as we kept working on it and introduced the multi-threaded architecture and introduced the GPU acceleration, it starts moving so much faster at like 60 FPS, 60 frames per second at full HD. And this was done under, without streaming to Twitch, it was a 3-second latency, and streaming to Twitch, it was under a 5-second latency, which I think is pretty good for live broadcasting sports. So this is going to go on for a little bit, practice in my room with it a little bit, and then we head out to the field, which is the on-field testing, which I think is very important, especially we're trying to do the soccer ball stuff. So. Please don't judge my skills here. The clip after this is going to be showing the video switching, and the ball bounding box won't show on that because I've reduced the alpha down to 0 so that, just looks like you're watching the normal game and it's going to be going from one side to the other. So I do want to mention something about the camera switching logic. That's the ideal situation. If you have the correct height where you can see the entire field and the entire grid is just the soccer field, that's how it's going to be. But for this one, for the demo, it's just that I saw the grid positions of where the half line would be of the 191080, 1080 grid, and then I made the dead zones accordingly. But in the future, I think we're redoing our soccer field right now, so if we have some place to host up the cameras on top, that would be lovely. All right, so let me go ahead and talk about what was out of scope and what our future development might look like. So as Haite already mentioned, we could go ahead and have a cloud-scaled operation for this because it's just going to be more scalable, more online, more available, and also if we need more computing power, because right now one laptop really isn't the best thing to do this on the field. And next up, we could also incorporate 360-degree views with drone footage, and we could build VR simulations based on that, like we have for the Champions League. So many different technologies already exist out there, and we're just trying to mimic that. We could have improved functionality of the stream overlay where it could be updated live, give more statistics or anything like, is there a foul or what the goal is or anything else that might come to your mind. As of now, we're only streaming to Twitch, so we would like to have multi-platform broadcasting, Twitch, Facebook, YouTube, whatever it might be. And then we could also add a system to detect highlights, as I was saying, for goals, fouls, and etc. The other thing that's not mentioned over here that would be lovely is that YOLO is really good with object detection, so it just makes it super scalable. We could do basketball, we could do American football, we could do any sport that really has an object that you want detected. So I think we'll be good to go with that and just tweaking a little bit of the algorithm here and there, and that'll be it. But thank you for your patience, thank you for your time, I appreciate that, and I am now open to questions. Yes, you're at the back. Which implementation of Python? Do you mean like the version? No, this is not CPython. And also, the difference is that I was reading up on this. There's mimicking parallel processing, and then there's true parallel processing that exists in Python. So I think my team and I did some research, and we worked on it and got it down to the true parallel processing for it. Yeah. Uh, I'm sorry. At this moment, all the code's on GitHub. I haven't looked at it for a little bit because we've been getting ready for the presentation. So to get to the nitty-gritties of it, I can provide you with a link and you could go over that. And if you have more questions, you can get back to me on that, if that sounds okay. All right. Yes.
Like the traditional methods of broadcasting, like cameraman. The algorithm also take into account what the cameraman sees.
So this is a completely automated systems. We're not going to have any cameraman. The idea is that you have these cameras set up and they're all streaming at the same time, right? And as of now, we only have one person from ESPN and they follow the camera just throughout the entire game, like a tennis game. But the idea of this is just to have a more engaged way to communicate with the school interest, you know, like everyone, wherever you are, you just sign on to Twitch and you can watch this game. You don't even have to pay for it. If you're watching on ESPN, you know, you need to have a subscription. So this is on the go, on the fly. Yeah. Yeah. Yes. Yes, of course.
When you got that lined out, is that ground level up to the sky, or are you looking at an overhead view in terms of kind of how you selected when it was switching to what quadrant? Kind of why you didn't make 4 quadrants, but instead made a 6x3 grid. And I don't think I'm oriented to.
Oops, sorry, 1 second. Oh, the one right before. Yeah. 6x3 grid because 1920 by 1080, just the math just works out to have a 6x3 grid. Yes, as I was mentioning earlier, the ideal situation would be that you have the cameras hoisted up so that you can look down at the field and you get the entire view up ahead so that we can section it off based on, you know, what we're seeing right here. Yes, yes, exactly.
Let's give this team a round.
You can ask
Offline.
I'm not going to answer that.
Okay, let's invite our third team. Their project is titled Enhancing Institutional Knowledge with AI, and it is sponsored by our own Seattle University Information Technology Services.
Where's the other microphone?
Do we have 2?
Where's the other microphone? There you go.
It's not working.
Oh, okay.
Oh, okay.
All right.
Well, take it away.
Hello, everybody. Is this on? Oh. Hello, everybody. We are group 16 from the Capstone Projects. Our project is called Knowledge-ASU. Essentially, we wanted to build an AI-powered chatbot for the school. The problem is a lot of the information is very distributed and often very hard to find. An example of this would be the library hours. They're not on the SU library website. So that was the kind of challenges we were looking to tackle. I'm George, this is Todd, Amin, and Kobe, and together we have solved this problem. Additionally, our sponsor is Seattle U, but Michael Skiles was our sponsor, and he's the head of SUIT. So everything we have done has been in mind with how is the school going to be able to hand this project off and maintain it for the future generations of students.
So for the scope of this project, we first had to build and deploy a chatbot powered by a fine-tuned LLM trained on Seattle University's information. Then integrate all of Seattle U's information into like one singular space for it to use, and finally for SU credentials. We'll have verification and login for SU credentials, and an intuitive web-based UI for Seattle users to use daily. Next slide. Now for the goals of this software, we first had to centralize the information, because right now trying to find the right information involves browsing through multiple different websites, outdated pages, and contacting other people. So this is inefficient, and our solution to this was to put all this data into one single knowledge base for our chatbot to use. Our next goal was to enable quick requests on important info at Seattle University, like research, technology support. So if users can get their answers in seconds, streamlining their workflow. Another goal that our sponsor gave us was to reduce the time spent searching for this info. So some searching endlessly through websites or having to contact someone and waiting for the responses. Instead, they can just use their chatbot and get their answers without having to wait on other people. And then finally, our final goal was to provide real-time accurate responses from the real-time accurate responses about professor resumes, their research, or from internal documents. So, and also it will also provide sources of that data, so you'll know it's true and you can verify it for yourself.
Okay, so for our architectural, one thing I very clearly was to keep it simple, very simple, because after we hand off this project, it won't be us handling it, it'll be Seattle UIT. The project is in general, so we made sure to keep it simple for them. So for our architectural approach, we decided on a monolithic architecture to keep everything simple, from fast development to simple maintenance. And for our data lake, we decided to keep it for cheap, scalable, using AWS Bedrock's knowledge base system. To keep it simple, keep it scalable up and down, depending on if we want to add more information to the knowledge base. And just again, like I said, we want to keep it simple. Next slide, please. So for our data lake approach, like I said before, we had it scalable. So if you want to, let's say, add documents from Confluence or CLU website or any source of information that you get from CLU, you can add that to our knowledge base, and our AI chatbot can directly source that information. So expanding the chatbot is just as easy as adding more information to the document. Really, it just depends on whether or not we have access to information. Like, for example, we don't have access to anything from SharePoint yet because the CLUIT has like security problems of whether or not if we take something from SharePoint, it could cause radiation, whatnot. Okay, next slide. Yeah.
Right. Now that you understand our data lake approach to our knowledge base, it's only fair that you understand what's actually in there currently. And so right now we kind of have three little lakes of their own, starting with a technology-related lake. From there, we pull from Seattle University's Confluence page, as Amin mentioned. In there, that includes a lot of basic how-to guides and troubleshooting on some of the common technologies here at the university. So that relates to stuff like printing, Canvas, how to add money to your e-account, that kind of thing. Next, we have another lake where we have some frequently updated websites, including the library website. That includes a lot of different hours for things like the spaces they offer, including the writing center, the math tutoring, the media production center, all things that you can like reserve, group study rooms, different laptops that you can rent out, that kind of stuff. And another frequently updated website is a website called schedule.seattleu.edu. That's kind of a calendar website where it includes a lot of information about upcoming events here at the university. So that's something we want to keep up to date as often as possible so that our chatbot can provide relevant responses. Lastly, of course, we have the Seattle U main website. This I have some gripes with because it's kind of organized a little weird, but what's lovely about it is that it contains at least a little bit of information on almost everything here at the university, because Seattle U uses it to kind of try and like attract other people to this school. So if you ask a question of this chatbot, it almost certainly has at least a little bit of an answer. It may not have a complete answer, but it can at least direct users to a better place. Next, I'm going to hand it back to Amin to kind of talk about how we can control some more of the chaos surrounding AI.
All right, so an important part of our project was obviously, since it's the accessible website from any Seattle faculty or student, we want to make sure that it adheres to the ethical values of Seattle University. So you want to make sure you can't input anything like hate speech, racial discrimination, or like asking to make a pipe bomb. We just don't want anything bad to be inputted into our website. So sadly, AWS's Bedrock knowledge bases only allow for one guardrail to be applied for each knowledge base. So we had had to really work for and strive to like tailor one guardrail for our knowledge base to kind of cover everything that we need. Like I said before, hate speech, discrimination. We also had to use like some prompting skills. I was the one who would prompt the website or the AI, but we had to use some smart prompting skills in order to make sure people can't access information or ask the knowledge base something that it shouldn't be asked. Next slide.
I'm going to talk about the UI. So we had a few more features, but they've been removed. So we're on to a basic chatbot. So we got the basic at the bottom. We got the query bar. We also some files with it too. And then above it, we have some demo responses that you can test out when you just want to test out the bot. And then right there above, we have our greeting message that just tells the purpose and that it's Seattle University chatbot. And then the responses are displayed right above it. And okay.
So one of the other things that we designed was a toolbar, which kind of looks weird on its own, but it'll make more sense when we get to the demo here shortly. So what we created it for is just for user convenience, some quick buttons so that they can perform some actions quickly. Quick buttons, haha. So what happens is you ask a question, the chatbot responds, and at the following the response, this toolbar is generated. One of the buttons included there on the far left is a copy to clipboard button, which is pretty self-explanatory. One click copies the entire response to your clipboard so you can paste it. Maybe you're drafting an email or a Word document, and it preserves any of that formatting. So stuff like bolded lists or hyperlinks to information. We'll showcase that in the demo here. Next, the other 4 buttons are all pertaining to feedback that you can give to the chatbot. So if it's completely optional, but if a user feels so inclined, they can mark a response as either helpful, not helpful, inaccurate, or inappropriate, depending on how they feel about the response. This marks that response in our database in the same place that the conversations are already stored with that corresponding feedback. We didn't design a system to do anything with that feedback yet, but hopefully a future group or even our sponsor himself can handle that now that we have that system in place. Next, I'm going to hand it back to George to kind of close us out with a few more slides before we move on to our demo.
We relied very heavily on AWS for this. There we go. We relied pretty heavily on AWS for this because Seattle U is affiliated with AWS. We used several AWS services. One of them was AWS Bedrock, which is the API gateway to access these models. We used AWS OpenSearch Serverless Vector Store. I know that sounds kind of crazy. Everyone keeps hearing knowledge base or database, and they don't know what this means. And we don't have enough time to go into it too much. But essentially, in short, what happens is there are special models that work with text that essentially vectorize statements in space so that statements that are similar to each other are grouped in similar space. And when a user asks a prompt revolving around a certain topic, other information in that space about that topic will be sent back to the LLM to be used as context for it to generate a response. Additionally, we used DynamoDB for the prompt feedback and conversation history on how to adjust how we're using the model. Our ID was VS Code, and the AI model and the knowledge base we were using were from AWS Bedrock. We used Anthropic's Claude models. At first, we used, I believe, 3.5, then 3.7 came out around winter quarter, and now that 4 is out, we're using Claude 4. Next slide. And as for our current progress, we have implemented the tooltips, as you just saw, for getting model feedback on how the users feel about our model. We've created the basic UI template. We have our basic guardrails that seem to be doing very well so far, and we'll be able to adjust those with additional testing once we open it up to the user base. And all of the public Seattle U information that is available on the public websites has been uploaded to one or another knowledge base. And eventually they'll be combined into a bigger one or into separate ones depending on how the school chooses to use it. And the biggest one, in my opinion, as someone who uses AI, is the URL checker. Because anyone who's used them knows they lie, and they lie confidently. So what's great is when our model gives a response, it attaches the URL of the place it found this response. So you can verify for yourself that, yes, this is correct. And maybe if you want more additional information, you can just click on it and go there and address that. And we have actually had some really interesting things we've addressed this quarter. We had some funny issues. For example, when we tried to copy the text out of the model, the copy button that Todd just mentioned, LLMs write in Markdown. That's how it shows up with the bullet points and all those titles and that stuff. So we had to write a function that would remove all of that and then let you copy out just the raw text. Additionally, and this is another funny one, at first, we agreed we wouldn't store conversation history just for now, for simplicity. But we do have it in the AWS database, we just wouldn't display it to the user. Now, the funny part is whenever we logged in, a new chat would be created, and if you left it blank, it would still get saved in the database. And the way we addressed that was doing what's called a sneaky reload. And you don't actually have that chat created until after the user has sent their first prompt, because you don't want to store empty chats for no reason. All right, next slide. And now we're going to go on to our demo.
Alrighty, you guys are going to have to bear with me here as I try and type one-handed, moving through this demo. Actually, we're going to close out of this. I already have you open here. All right. So when you visit our website, this is going to be your landing page. And since it's only available to Seattle University family members, students, staff, and faculty, you can actually go ahead and sign in with your SU credentials by this button here. This is a screen I'm sure that's very familiar to all of you. And I don't know why that autofill is there because that's not actually spelled correctly. Oh, wow. Wow, I can't even, well, okay, well, maybe I need it because I can't even spell my own name. So here I'm just, of course, typing in my username and password, praying that I get it right the first time. And our very familiar multi-factor authentication. Yes, I know who I am, but this chatbot doesn't know just yet. But after I successfully verify my identity, I can click the Stay Signed In button, which isn't actually true. And now I'm actually greeted at this bot. I'm going to talk for a little bit. Yeah. Before I actually truly start this demo, I do want to preface one thing. AI is extremely powerful, and the breadth of its capabilities are vast. For the purpose of this demo, I'm just going to try and highlight the ways you can interact with our tool. So I'm going to ask some very simple questions with very simple answers. But I heavily encourage you, please, 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 during the Q&A time or afterwards, come find us at our poster if you have some more complex questions you think that this might be able to answer. Now, could you kind of go back? Could you hold it for me? Oh, yeah. Yeah. All right, so starting simple, maybe you want to know more about our faculty advisor, Dr. Zhu. Maybe you didn't even catch his first name. See if you only give it his last name. Who is he? So it's going to take a second to think, of course. And right away, it's already said it's found information about Dr. Zhu at the university. And as George was mentioning, it's actually going to verify that source for you. So it's not going to provide you any bad links. You can reach Dr. Zhu. He's a director of Master in Science, blah, 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 blah. And let's say you don't trust this information. So like George was saying, let's say, oh, his phone number is 296-5515. Is that really true? Why don't we go find out for ourselves? It links you directly to his profile. We can scroll down and verify that information for ourselves. That's his correct phone number, so yippee. The other thing I want you to notice is this toolbar. So it makes more sense in the context here, where you can kind of copy a response to your clipboard. So let's say I really like this response. I'm going to go ahead and copy it. It lets me know that the response was copied. And if I go to a Word document, we can close our slides now. I don't need to save anything, thank you. And go ahead and paste it into a Word document. We can see, as I noted, it kind of preserves any of that bulleted lists or even the link itself. So I can open the link here and take you back to his faculty profile. I can also think, oh, hey, this response was helpful. It lets me know, thank you for your feedback. Maybe I accidentally clicked the wrong one and actually think this is an inappropriate response. You can go ahead and change it. Or maybe you clicked one and you don't want to leave any feedback at all. You can actually unselect your response as well. So again, just to kind of go through the ways you can interact with it, as we mentioned before, you can attach files. So right now, this just includes images, so PNGs or JPEG formatted images. I've got one here with kind of a garbage name, just so that you know it's not using the name of the file to discern anything from the image. And all I'm going to say is help. And I'll kind of zoom in on the photo here. This is just a generic Office error. So it's saying, Office, something went wrong. Sorry, we ran into a problem, and it's got a little error code for you. I work in IT as well, and I can't tell you how many tickets I've seen like this. In fact, actually, you're kind of lucky if you even get a screenshot. Sometimes it just says help, and so you have to reach out to the user and beg them for anything else. But in the time that I'm talking to you, it's actually already read the image, extracted the error code, and given you potential solutions. Obviously, I don't have the error in front of me to try these solutions out, but maybe I go try it out and I think, hey, that wasn't actually correct. I'm going to rate this response as inaccurate. The other piece of information I kind of want to highlight is that this knowledge bot has access to the current time. which seems kind of silly, like who really cares about that? But that actually opens a whole new world of questions that you can ask it. Something like, is the makerspace open now? The keyword being now. Without that current context of time, knowing that it's 3 o'clock on Friday, it's going to have no idea whether or not that makerspace is actually open. So we'll give it a second. It's going to have to check the current time and then actually go verify the makerspace hours based on the current time, Friday at 3 p.m. It's currently closed. Oh no, I don't believe you. You show me the information, please, please, please. We'll go check out the website ourselves, scroll down and say, oh man, Friday or Sunday it's closed. Well, okay, well, those are the basic ways to interact with our bot. Does anybody have any questions for us or for the chatbot? Refresh our settings.
You said you opened it up to the school yet?
No, right now it's only open to us as a team as well as all of the Seattle UI team members.
We have one big issue that we need to address first, and that's the cost issue. Because it grows exponentially as you keep asking more and more questions. So we need to implement the guard of like, you can only ask X number of questions before we like tell you, go start a new chat.
It's also not a huge concern right now because although we talked about having like sensitive information, all of the websites are public. So everything we're pulling from is public. So there's nothing we're really protecting at the moment, but it's kind of just something we're setting up for the future in the case that they do add, like they want to have role-based information, that system's there for them. It's hard to give like an exact estimate for that. I can tell you we've spent less than 500 on the year for testing, which is really low considering building these knowledge bases is the most expensive part so far. That's about all I can say. Our sponsor hasn't been concerned on the cost and he spends quite a bit of money. So I think he's pretty happy so far. Yeah, I think so. Professor Mikowski. Zero, because we don't train it. It is a pre-trained model, and I guess I'll let George go into it a little bit more, but we don't train it on this information.
When you want to introduce an LLM to new information, there's two ways to do it, fine-tuning, and then just, that's what the knowledge base is for. When you fine-tune, it's very expensive and time-consuming, and you need a lot of data to make sure it answers the correct way. Meanwhile, with the knowledge base, you just give it the context, and because these are such competent chatbots, using previous context, they're able to then generate an appropriate response.
We're done? Yeah. It's a pleasure working with you.
Okay, so good afternoon, everyone. Welcome to the Project Day 2025. My name is Prerna Janeja, and I'll be the host for the session. Thanks for all of you who are here in person, as well as everyone who is joining us over Zoom. Thanks for supporting our students. So there are 3 amazing presentations lined up for the session. Each team will present for 15 minutes, followed by 5 minutes for Q&A. And let's get started. So our first team is already here. They're gonna present their project titled College Autofill Extension, which is sponsored by Paige West. Let's take it away.
Does it work? Hi, everyone. Hi, everyone. Can you hear me? Okay. Good afternoon, everyone. Thank you for joining us. We're Team 3, Paige West. Our team consists of myself, I'm Adam. We've got Buka, Kevin, Ethan. Our faculty advisor is Professor Chen. Our project is about a web browser extension which is aimed at revolutionizing the college application process. The college application process today is often overwhelming and inefficient. Imagine being a high school student, having to apply to different colleges, and each application requires you to fill out the same information again and again. This redundancy can lead to frustration, errors, or even deter students from pursuing higher education altogether. Our app addresses this pain point by automating the process. It gathers students' information, stores them securely, such that applications becomes as simple as a click. The goal is to minimize repetitive data entry, reduce errors, and save students valuable time. That way, students are more likely to use that time to work on their personal statements, visiting campuses, and preparing for tests rather than being bogged down in paperwork. With this project, we aim to not only simplify the application tasks, but to foster an environment where students are encouraged to pursue higher education with fewer barriers in their way. So here's the outline of our presentation. In a moment, I'll go over our sponsoring company background. Then Buka will cover the problem statement, opportunity, solution. Then he'll hand it off to Ethan to cover the key feature, tech stack. And then we're gonna finish up with a live demonstration of how the plugin works, demonstrated by Kevin. Our sponsoring organization is Black Page West, which is a consulting company based in Seattle, founded in 2016. One of its CEO is Michael Witherspoon, who's been our liaison throughout the project. They specialize in data analytics and small business acquisition. The current project is to enhance and make education accessible for younger generation.
So for the problem statement, the main problem we are trying to deal with is the time-consuming process of dealing with college application forms. As you can see, this is just the Common App, so a user would have to go through this entire section along with the next tab, and then do this entire section, and then move over to the next tab and do the same thing. So it's very inefficient and time-consuming, and if you have to apply to multiple different colleges across the US, you may have to use different platforms and deal with multiple different systems. And people also can have limited counselor engagement with their project, so they may not have access to specific resources or faculty that could help assist them in this process. So it's a college outreach challenge. So the opportunity here is that we're seeing high school and younger BIPOC students show less interest in post-secondary education because of these lack of accessible opportunities or just not having the knowledge to find the specific opportunities that may interest them. Applying to universities or vocational programs is both time-consuming and inefficient, and dealing with multiple platforms is just creating unnecessary barriers of entry to some students. And it ultimately leads to college programs and trade school programs potentially getting less talent if people are discouraged by not being able to do those. And on the right, you have this graphic here that shows some of the biggest sources of stress for high school seniors. This was taken in November 2023. And it shows that almost 60% of people said applying to college was the biggest source of stress in their senior year. So for the solution overview, we worked with Black Page West to design and implement a web browser plugin that simplifies the college application process for students. It automates data entry, minimizes errors, and saves time for students and counselors. It also ultimately just enhances student support and broadens access for schools to discover talent. And this is the homepage of our extension. So on the bottom left would be the form page where the user puts in their information. The homepage itself would take you back to this page where you click the autofill button and fill out the whole form, basically.
So for our key features, we had four that I'd like you guys to. So for the first one, this is our data input and form management page. We needed to implement a way for users to be able to input their data, and we designed a simple yet efficient form page that can store users' data, like their name, their email, phone number, etc. Info you would see on most college applications. And we wanted to keep the layout simple so that students could not get confused and are able to focus on the important part, which is applying to applications. For data storage, we needed a way for users to securely store that student data for future use. So we decided to go with MongoDB, and in short, this is served as our database because a lot of our information, for the most part, is independent. So MongoDB excels at kind of unstructured data. So that is why we decided to use it as our database. For user authentication, there's a lot of important and private information on college applications, which is why it's important that we securely or make sure that this data is securely stored. And to do this, we implemented a system called OAuth 2.0, which allows users to log in with Google or other things like GitHub and whatnot. And this allows that kind of authentication process to be handled by trusted sources. And lastly, the core functionality of our program, which is the autofill functionality. This is stored in a plugin, as you see at the top right, through a Chrome extension, and this will we have two buttons that kind of handle the autofill itself, and this will use that stored data in the database to fill it within the college applications.
All right, so this is the video demonstration of how the plugin works. So users will go to their common app and sign into their account, just like what I'm doing right here. And once they're signed in, once they go to the common app tab, our plugin will pop up immediately, just like so. And they can click on the Google logo to sign in to their Gmail, just like so. And once that's done, they'll be redirected to the home page. There's many buttons. You can go to settings, you can log out. There's a bunch of buttons there, 2 buttons for the autofill system, and then there's pages you can go to for different purposes. So we'll go to the form management. And here you can see is our form page. So the little cool thing about a form management page is that anything that you fill in the form will be saved throughout. So I will demonstrate to you here, like me modifying the fields and it being saved. But basically, whatever you fill in the form will be saved throughout. That way, users don't have to fill in the whole form every time they want to change something. So they can just change a specific field they want and not have to go through the required questions. Just changing a bit information so I can show you guys how it's like. Do the language, because why not? Right, then we can go exit the form page. Everything's filled. Go back to the plugin. Log in, go back to the form page, and the information is there, saved. And okay, and then once the user has filled in all the fields in the form management, they can go back to the common app and they can try to see other features. So now I'm going to demonstrate to you the autofill feature. So as you can see, the home page, there's 2 buttons, the white and the orange one. The white one basically just fills in a section. I'm going to demonstrate to you right here, just like so. So instead of having to fill the whole thing, you can just fill one section so that no time is wasted. As you can see, the answers I modified is filled in into corresponding fields. Like that. And I think I did one more. Just like that. And then the orange button is basically what people's gonna use most of the time. Basically it fills the whole form from the beginning to the end. All you have to do is click that button and let the magic happen. There you go. Okay. So basically, it's going to be like this when it's filling up the form. And while this goes on, we wanted to say that there are some fields that we choose not to fill in. That's because it's like the user's consent. Like there's a fee waiver that you have to sign or some social screening number you put. It's not required, but you can. So we decided not to fill those in because they're sensitive information. And basically just like that, it fills the common app. And then once the user's done filling in the app, they can just log out and later they have to sign in again. just like so. All right, that's it for the video demonstration. So basically, to sum it all up, we partner with Michael, Blackpage West, to enhance the experience of trying to apply to college and universities by implementing a plugin which basically lets which basically autofills all your information to the common app. That way, people don't have to do that redundant process of having to fill their information to different forms. All right. Any questions?
You were on for God's class?
Any questions? Sure. Yeah.
What was the most difficult part about working on this project?
I can answer. Yeah. We had to implement the like OpenID OAuth 2.0 login system. I think that was kind of difficult to work on because we had to learn how like token logging kind of works, and it's just a different process than like what you're used to. So
I think in general though, I think it's schedule conflict because we're working for 3 quarters and our schedule keeps conflicting. So having to keep track of those and having to meet in a specific time is also kind of hard to do. Yes.
How did your project change from when it was first formulated up today?
I can't answer that. So basically, what we had planned originally was to have an application that does the autofill function, but we figured out that because of cross scripting and all those other problems that it wasn't feasible. So instead, we changed it into a plugin like you saw, and I think that's the biggest change that we made from the beginning to the end. Any more questions? Oh, sure. Yeah.
I like some of the integration points you described. Common app, I think that's a very common thing. If I remember the user flow here, the users entering their information, you should consider pulling that information from other sources of integration. That's
Yeah,
That's just us.
Thanks, years.
Any more questions?
Okay, let's give a round of applause. You can invite our second team to come and please set up. So they are going to present their project titled ReadEase, providing accessible, individualized AI-supported reading. And this project is sponsored by Thoughts.
Yeah, right. You have to share a screen.
Hello, everyone. Thank you for being here today. Sorry, audio technology. Thank you for being here today. We are the Thoughts Cost team, and we're thrilled to share with you ReadEase, our year-long project that bridges the gap between technology and accessibility. Our focus was to leverage AI to enhance accessibility for students with disabilities. Let's dive in. Before we start getting into the details, let's introduce the team. I'm Adriana Martinez-Lainez.
Hello, my name is Rina An.
I'm Awesome Malhotra.
Hello. Hello. Check. I think this is working. Hi, I'm Jay Dahia.
And we worked alongside our sponsor, Anthony Washington, our sponsor tech lead, Jaden Dubala, and our faculty advisor, Lisa Mikowski. Each of us played a critical role when it came to designing and developing this platform, and we're excited to share that with you today. At ThoughtsCause, we wish that the education system empowers every student, not just the majority. However, traditional learning methods have often overlooked the unique needs of students with learning disabilities. Our focus was to create a website with teacher and student profiles, leveraging AI technology for accessibility tools. This includes text-to-speech, text summarization, and assessment functionality. Our vision is simple: a world where every student, regardless of their ability, has access to adaptive and supportive learning environments. We're not just building a tool, but a future where every student feels seen, supported, and empowered to succeed. This has driven our developmental process for the past 9 months. Now I'm going to go ahead and pass it off to Asta for our key functionalities.
Thank you, Adriana. So we have 3 main key features. Our first is platform integration assessment. Our second is multi-model learning support. And our third is file and data management. Under platform integration assessment, teachers will be able to create customized assessments that are tied to uploaded books. And then students can go take those assessments and then receive back automatic grading. And then under multi-model learning support, these are just our AI implementations, such as text-to-speech, text summarization, and our AI chatbot for reading comprehension. And then finally, we have file and data management, where we'll be able to store student progress, assessment scores, and the AI model usage data. Now, this is how our system is designed. So all our components, such as the teacher and student interfaces, as well as the databases, are all combined into a single system. And all of our external services, like our AI implementations, are also added directly into the website. And on the right side, you can see just more of the specific details of our project. Now I'll hand it off to Rena.
Awesome, thank you, Asta. So now that we've reviewed some of our technologies, let's dive into one of them. Our database, which serves as a digital library and gradebook. Now, the database has 3 primary functions. First, it manages user information on teachers and students. Second, it stores assessment data, which includes the questions themselves, as well as the correct answers to the questions and the student answers to the question. Finally, it helps track activity and progress, and this includes the interactions students have with our chatbot, as well as the automatically graded assessment scores. Now, moving on, I'd like to introduce 2 core functionalities of our project. To start, a teacher is able to create an assessment. Teachers will provide basic assessment information such as the title, the students who are assigned the assessment, as well as the book the assessment defines questions for. We have multiple choice questions that can be defined by the teachers, and each assessment must have at least 1 question, and the teacher can define up to as many questions as they desire by clicking the Add New Question button. Upon completing the creation of the assessment, the teacher can click the Create Assessment button, and the assessment data will be stored in our database. Next, students are able to take the assessments that were created and assigned to them by their teachers. On the upper left, we have the assessment title. On the upper right, we have a timer, which keeps track of the time the student has spent on the assessment. Now, this is a metric which helps teachers determine how challenging or engaging the assessment was. Below, we have the multiple choice questions. Students are able to only click 1 option for each question. And upon taking the assessment, students can click the Submit Assessment button, and their answers will be automatically graded, and the data will be stored in the database. Now, that I've covered some core functionality, I'd like to pass our achievements and accomplishments of this project to Jay.
Okay. Thank you, Rena. So let's take a look at our project milestone and also our future vision for ReadEase. For teachers, we have built the ability to create custom assessments, which can be directly linked to the books that they upload on the database. The teacher can also view the progress of the students through visual charts, which can help them gain insight on the students' performance. The teachers can also create multiple assessments, and they will all be shown on the student's dashboard. For students, we have built a book reader where the students can read the books that have been uploaded by the teachers. The book reader also supports tools like changing the font style and changing the font size for better reading. In the book reader, we also include tools like the text-to-speech and the AI chatbot for more support and for instant clarification. Our future vision for ReadEase is key features that can be implemented in the future. Some of them are included as follows. The first one is the view progress page, where we can also display the data for what books have been read by the student. We can also provide the functionality for the teachers to let manage the students on the dashboard itself. Also, we can change the question format for the CREED assessments to let teachers change the question type. For example, providing short answers or fill in the blanks instead of the multiple choice questions that are already present in ReadEase right now. And also improving the AI model in the book reader for better responses to the students. One more key functionality is extracting the chapters of the book in the book reader so that the student can have an easier time switching between different pages and also going to a specific portion of the book. Now I'll talk about how we did the testing for ReadEase. We started by focusing on the user, and we tested ReadEase from a user's perspective to check if the correct input is giving the correct output. After that, we looked at the accessibility to make sure that ReadEase is a platform which can be used by everyone, including people with disabilities. We complied with the global accessibility standards to make sure that ReadEase is easy to use. Next, we look at the user feedback. We directly ask teachers and students to try ReadEase and get feedback from them. Their experience helped us gain insight on how we can improve ReadEase and what can be tweaked for better usability. Next, we focus on the design of ReadEase. We made sure that the UI is bright so that people can easily view the website, and also make sure that it's responsive. And lastly, we focused on the performance to make sure that ReadEase is fast and can be used by multiple users under peak usage. This concludes our presentation for ReadEase. Now we'll move on to the demo part where Rina will show us the student dashboard.
Awesome, thank you, Jay. So this is our login page. This will remain the same for both teachers and students. The different slides are the credentials. So let's try logging into our student profile. Upon logging in, we'll see two functional drop-downs, books and assessments. I'll be covering the book section. In the book section, the user is able to select a grade level to read from, which will populate a list of appropriate books. Upon selecting a certain book and clicking the Read Book button, we are brought to our book reader, which is a reading interface. There are two views. In the PDF view, the student is able to read the book as it is printed. In the text view, only the text is extracted. And there are various font styles to accommodate different reading disabilities and visual impairments. For some people read better with serifs, some don't. We can also change the font sizes accordingly. A core functionality is the ability to highlight a portion of the text. And once we click the Speak Selected button,
Tasting them. Only he was very hungry.
Hear the text be spoken. For the purposes of the demo, we have a short portion selected. However, users can select larger portions, and as they read, they can read along or also use the chatbot below. In the chatbot, we can ask the chatbot to define a certain word, summarize large portions of the text, or explain a phrase. Let's try asking the chatbot to define what an assessment is. We get that the definition, which is the act of evaluating something. So once the student has finished reading, they can click the back to dashboard button to return back to the home page. Now that I've covered the book section, I'd like to pass our assessment section to Asta.
Thank you, Rina. So under the assessment section, you can see all the assessments that have been assigned to the student. To take an assessment, the student can click the Take button, and it'll take them to the assessment. As mentioned before, at the top right, you can see the time elapsed, as well as all the questions and the answer choices. Once a student is finished taking the assessment, they can go ahead and click the Submit Assessment button, and it'll guide them back to the dashboard. Now to see their assessments, they can go back to the Assessments tab and click the Completed Assessments button. Here, you can see all the assessments the student has completed, the date they submitted it, the score, and the time it took them to complete it. Now I'll hand it off to Adriana to start talking about the teacher dashboard.
So like previously mentioned, the difference between a student and teacher profile is by the credentials. So this time around, we're going to log in through the teacher credentials. So upon a successful login, we are greeted with 4 functional dropdowns, which includes students, books, view progress, and assessment. I'm going to focus on the left side of the page. So for the students dropdown, we're greeted with all the students that are particularly assigned with this teacher. The teacher has the option to add more students. At this time, we're not going to show the functionality of this option as it is currently a work in progress. On the view progress dropdown, we're greeted with the same list as above with one key functionality, which is viewing the student's data. We're going to go ahead and view the data for Ever. So for student Ever, we're greeted with a whole bunch of information and data, which is crucial for the teacher to really see where the progress is of a student. Where we can see on the left side, we have chat history, which is all the chat history that Ever put into the chat bot in their profile. So you can see that we have defined assessment, and based off these questions, the teacher can distinguish what particularly is the student struggling on or something that they've mastered. To see something that they've mastered, there is a data visualization or a graph on the right side that shows the assessment scores of the per assessment that the student has taken. And then below we have the incompleted assessments, and this can help with the teacher distinguishing, what is the student avoiding or just diving right into. So now we can go back into the main dashboard, and I'm going to pass it off to Jay for the other half.
Thank you, Adriana. So on the right side of the teacher's dashboard, we have the books and the assessments dropdown. Under the books dropdown, we can see all the books that have been uploaded by the teacher on the database. We can click on Add Book to add a book to the database, where the teacher needs to put in the book title, the author's name, select which grade the book is being assigned to, and then upload a PDF version of the book and upload it. Going back to the dashboard, under the books dropdown, again, we can see the search functionality. We can search for a specific book, and that will show the result for that book. For the assessments, it's the same dropdown. It shows the list of assessments that have been created by the teacher. The search functionality also works for assessments, where they can look up for a specific assessment. In front of each assessment title, there's a view button. When clicked on the view button, it will take them to a preview of the assessment, where the teacher can view all the information that's being stored in the assessment, from the assessment title to the book that it's being linked to, the students who have been assigned the assessment, and the questions and the correct answer as well. There's an edit assessment button on the page, which when clicked will let the teacher edit the assessment as well. They can change all the aspects from the title to the students who have been assigned the assessment, the book that the assessment is linked to, add questions, remove questions, change the questions options, the correct option as well. And once the edit is saved, we'll be back to the view progress. The other functionality in the view page is to delete the assessment as well. Now returning back to the dashboard, under the dropdown, there's a add assessment button, which when the user clicks will take them to the add assessment page, where they can create new assessments, input the same data they have already showcased, which is the title, the student's book, questions. And once the assessment is created, it will be saved in the database and will be reflected on the student's dashboard to take the assessment. And this concludes our demonstration of ReadEase. Thank you to our sponsor, Jaden and Anthony, for their support, as well as our faculty advisor, Lisa Milkowski, for making ReadEase a success. And we're very proud of what we have achieved with this project. Thank you. We're open to question and feedbacks. Yes, please.
I have a question about AI, particularly the one where it's a voice that kind of reads back to you. So like the development of AI these days, there's a lot more human-like nature to AI voices, and I was wondering if that's something you foresee implementing into these, just to make it like more like human accessible for like children as well when they're hearing voices being read back to them.
That can definitely be something achieved in the future. Right now, our AI model is not very strong where it can mimic human voices. But once the AI model is revised again and again, and we have like further iterations, once it gets smart enough to talk like a human, then that can definitely be put as a feature as in ReadEase. And maybe the book reader can also become a audiobook listener where you can also listen to the book. Yes, please.
Facilities for people who are like reading the books. But what about for the assessments as well? I assume that if they need help reading, that they're probably going to need help assessment. Like they might not be able to actually read the questions.
Yeah, so that's something we actually discussed in the beginning of our developmental process, where's the line on the type of help that we can add. Of course, we can't add the chatbot when it comes to the assessments, since that can lose the integrity of the assessment. But I do foresee in the future where we can implement those customizable fonts and any further implementation in regards to the highlighting of text and reading back that can be pretty helpful for students who are struggling with a reading disability or even like a visual impairment. And that is something that we got during our user feedback sessions, and it's something that we can definitely see in the future.
Yeah.
I saw that you guys basically, so the credentials basically allow you to log into either the teacher's dashboard or the student's dashboard, right? You guys think it'd be a good possibility to have like an admin login to like help like manage the teachers or like courses, course material, something like that?
I can take that one. So right now in Teachers Dashboard, we have a work in progress add student feature, which will let the teachers manage the students. As for the teachers, they can sign up from the login page. But if you want to manage the teachers' roles as well, then that can be done from the database, which we can provide the access. But in the foreseeable future, yes, we can also add a third dashboard for the admins, which can also manage the teachers and the students. But for now, we're just keeping it simple and what the sponsor is expecting from us.
About supporting students who have like reading disabilities. I know with reading disabilities are not always rooted in that visual impairment, not necessarily. They're kind of based in language and the comprehension. So how do you support students who you have that implemented speech to text? How do you support students who have those auditory deficits, or for example, like when you were talking about the books, what if the sentence questions are too complex? How can teachers restructure those questions to support with your AI?
I'm sorry. So just for clarification purposes, so is it like a way for teachers to gauge if students are truly understanding, or if there is another way to restructure the text?
Yeah, so I'm wondering, like, you have different assessment questions based off of the books that they're reading in class. So based off of like their performance and teachers seeing like, okay, this child is having really difficult with more complex based questions. How can the teachers use that information? Are they able to change the level of complexity of the questions based off of your chatbot feature?
Yes. So you are currently working on giving more metrics to teachers about student activity and metrics so that teachers can truly understand how difficult this task, the assessment is for the student. So currently how it works is we have our chatbot information in the view progress section. So for example, let's say that students are asking the chatbot to define words a lot. Then the teacher can understand, okay, but this student is having trouble with either defining a word, vocabulary, and something along the lines of that. So what they can do is they can then go to create assessment and create an appropriate assessment. It's the same for if they have challenges in the current assessment. Let's say that the time spent was very long. and the score wasn't very great for an assessment. The teacher could check in with the student, ask how it was, and if the student said he found the wording difficult, the teacher can either go in and edit the assessment accordingly or create another assessment just for the student.
I can also add on to that. So when we were hosting our user feedback sessions, something that came up was like, how can this came from a teacher perspective? How can a teacher go ahead and create a curriculum plan for a student, automatically using this AI software? And when ReadEase was first proposed, that was the ultimate goal. However, there's a lot of steps to get there. And this is like the first step to getting the comprehension and understanding of what's going on with the student while they're reading. And we hope that in the future, we're able to create those curriculum plans. But at this time, those curriculum plans are guided by the teacher based off the data that they're given. And so this is step one, and there's still so many more steps to get to the point where a student can be fully supported and a teacher can be fully supported as well.
Great presentation.
Let's invite Michael Group. They are gonna present their project on NASA-ASU web-based game, which was sponsored by NASA Psyche.
Oh, wait, I need to share sound. Oh, I thought we were crossing over so you can see. Oh, well. All right, hello everyone. We are a part of the Psyche team, and we have been developing a web-based game over the course of the school year, and so we're excited to tell you everything that we've been working on. So just to get started, just to introduce our team. So my name is Grace. Here we have Kevin, Colin, Hanjin, and Lyle. And then our faculty advisor is Dr. Nate Kramer-Herman, and our ASU sponsor was Dr. Cassie Boak. And just to start off with a little bit of background about our whole mission and why we're doing this. So Psyche is the name of the asteroid that's orbiting the sun between Mars and Jupiter, and it's also the name of the mission that is going to visit said asteroid. And so this whole mission is being led by Arizona State University through NASA's Discovery program. And so here we just have a short timeline of the beginnings of the project. So 2011, the Psyche team submitted their proposal to NASA. And then in 2016, they were selected to submit a concept study. And then finally in 2017, they were selected by NASA to actually carry out the mission.
All right, so what is the Psyche mission? So as the website says, for the first time ever, we are exploring a world made not of rock or ice, but of metal. Psyche's metal composition makes it unique to the other asteroids we have studied in the past. And then why does this matter to us? So scientists believe Psyche may contain parts of the core of a planetesimal, and these parts collide together to form planets. And since we can't study the Earth's core directly, Psyche may provide insights into Earth's core and how other terrestrial planets were formed. And the Psyche spacecraft launched on October 13th, 2023, and it will arrive in August 2029 and orbit and observe it without landing.
So I'll be talking about our project requirements and our design decisions. When the NASA-ASU team proposed this project for us, they made it clear that the spacecraft would not be arriving to Psyche until 2029, over 4 years away. So building excitement for this mission was really important. And we decided to do that by letting the user feel connected to the mission, by playing a scientist, the lead scientist, to walk through every phase of the mission timeline. And so we created mini games to run through each phase of the mission timeline. We created a web-based game that can run on regular standard computers, on all major web browsers, Chrome, Firefox, Safari, and Edge. We used the Godot engine to create our game. Our target audience was elementary to middle school aged kids. And we decided to focus more on the entertainment side of our game rather than the education, just to create a more memorable game to kind of build the excitement for the Psyche mission.
So as Colin mentioned, we use the Godot engine for a few reasons. The first being that it is free and open source, which means that at the end we have full ownership of our project. It's built on a node-based system, which makes it really easy to visually organize the game elements. And once it comes time to export, it makes it super easy, just a 2-click export to the web. And for our scripting language, we use GEscript, which is a native script to Godot. And to edit this code, we use either their built-in editor or Visual Studio. So a quick breakdown of the game itself. Our introductory level is an escape room type of game. This establishes the storyline of Kuiper, our little character making their way to the control room. The player has to answer questions in order to progress. Once they're at the computer, it's a very quick time event to launch the SpaceX Falcon Heavy rocket. And from there, we get into the first level, which is the meteoroid dodging level. This simulates plotting out course corrections in the event of oncoming collisions. And once you get past these collisions, you transition into the Mars slingshot. This is actually a real-life maneuver that they will be performing at the actual mission, where they use Mars's gravity to essentially accelerate and conserve fuel. And once they reach the asteroid Psyche, they will begin to analyze it. This minigame simulates using the instruments over the 4 different orbits that the Psyche spacecraft will make. And once that is complete, they will send the data back to the mission team, where we have a little sign-off minigame. This is like a word bubble style of gameplay where the player must type out the words in order to sign out the mission.
And so here's our project diagram. Our project diagram is just a game. It's made of our game client, which contains our stuff, which handles user interactions and displaying our content, along with our asset manager. And alongside that, it has our browser API. Alongside our game client, it has our browser APIs, which handle displaying everything and such as sound, and alongside sound to the users who are playing on web. And now on to our actual video demo. Yeah. Do we have to? Yeah. Did it touch? Just gonna stop share.
So the first part is our character Kuiper, and this is just some dialogue about the mission itself. These parts are sped up just for demo purposes.
And so then once this is finished, we'll move into the escape rooms. And so each room littered throughout, there are different hints that players can walk up to, and a little message will pop up that they can interact with it. And then each room has different questions that they have to answer before moving on to the next room. And so each question is actually randomized, between 3 different options. So that makes it a little more replayable in that way. And then once Kuiper makes their way all the way into the control room, this starts our first minigame. And this is where we launch the rocket. And this is actual footage of the launch itself. So once that goes through, we had a little bit of an audio issue with the recording itself, but there is audio of the actual launch countdown from 10 sort of deal. And then once that takes off,
Right, and then we get to the course correction simulator. This part, it'll go through multiple levels of different types of debris that we encountered. So this first one, this debris stationary, is just an intro for players to just get used to how the level works. Second one, the debris will move for every tile that you move. So players have to view the grid in advance and see how they move to be able to successfully reach the end of the tile. And this one's a combination of all of them, where just have to plan way in advance, and it's okay to mess up. That way you can see how the course goes, and then at the end, just a little blurb about how they dodge how they do course collisions.
So this is the Mars slingshot level. It consists of 2 levels. One is an intro that you just fly across the screen. This right here is the actual slingshot maneuver itself, where you're using Mars gravity assist to just set the trajectory and conserve fuel by doing so.
All right, so once the spacecraft reaches the asteroid, this is a simulation of scanning the asteroid at the right places. As you can see, there are visual, and you can't hear it right now, but there are also audio indicators to let you know where the correct place to scan is. And for each orbit, you can differentiate them by the color of the asteroid. And we also have just a very short blurb on the side that describes the current instrument that you're using and what its purpose is.
And after this, we have a little just comm section, just watching it spin around as text on the side to explain what the mini game is, and a little bit of hints about the mini game, like helpful tips and tricks, like help explain. And after which it goes to the side and starts sending words to the end. As you type in the words using your keyboard, it will pop up information about what is written there. So like the instruments will say what type of instruments there are. The multispectral imager will tell you like about the multispectral imager, and so on and so forth. And this will go through just a large set of predetermined words. And if you miss a word, it'll come back around as well. And some of these so-called words are 2 words combined into one part. And yeah, after all the words are done, everything will fly off screen, and then we go to the credits, which show how, everyone who's worked on this, and along with everyone who we had tests in the back. And just give credits to everyone who helped us with the project. Thanks to our sponsor, Nate Kramer Herman, alongside our wrong direction. Sponsor Cassie Bowman, and the professor who helped us, Dr. Nate Kramer Herman. And now to back to the stuff. To our reflection about stuff that we think should be improved on about project and maybe things we want to change as well.
So if we were to go back in time and do this again, I think the biggest thing that we would change is we want to have more cohesion between each level. And the way we would do that is by implementing more cutscenes into the game, just to kind of give the storyline a more continuity.
The things that we were satisfied with and would keep the same. We really liked using Godot as an engine. We thought it was simple and intuitive. It was a great starting point for us, as well as just the general timeline of the game, just the storyline. Using the natural phases of the Psyche mission to create a storyline for our game felt really beneficial to just building a sort of connection to the mission. And then finally, just the balance between our entertainment and education. We really liked how it turned out. It is an educational game that is fun for for the users to play.
And now any questions?
And then this QR code, unfortunately, we don't have mobile functionality, but you can just scan this, keep it for later sort of deal, if you want.
And if you have not played the game already, we are on floor 2, where you can come play it for yourself. It may be for children, but I'm sure you guys will have fun playing it as well. Thank you.
For the images, for the sprites, did you find them, or did you create them, or who paid for it?
So for the escape room parts, I did already have an asset pack, but then I modified a bunch of it to make it relevant to this game.
For my assets, I didn't make some of them, but most of them I just look up some of the websites with royalty-free images.
Yeah, for mine. So the images that you see of the asteroid itself, they're actually from the Psyche website. I just applied a little pixel filter over it. But that computer UI around the edges, that was actually a 3D model that I found just on the web. So I zoomed into it and took a screenshot of that. And yeah.
Yeah, and we pretty much use this. Me and Colin also use similar assets to what they use, and we also just use the same thing that mostly from the Psyche.
Yeah, it's a children's educational game, but also you guys saw in here, maybe great with the difficulty system.
You just said like just increasing difficulty. Yeah, so that's something that we had talked about at the very beginning, was creating that difficulty and even just kind of realism. But as we kind of went forward, just kind of creating new events and kind of instantiating these new objects just did not work with our timeline.
Yeah, so we actually had a beta testing session at a local elementary school. And then we tested with 3rd and 4th grade. And the consensus essentially from the 3rd grade was that it was a little too hard. And then the consensus from the 4th grade was that it was like a little too easy. So we were considering doing like a difficulty selector, easy to hard, but then we were kind of like, well, you know, it's pretty medium. 3rd, 4th grade was, you know, in the center of our target audience, so we kind of just left it at that.
Yeah, I know you mentioned why you use good like open source and stuff, but why not Unity? Unreal, for example. I know because I think they respectively use like C# for us.
Yeah, well, I mean, the main reason was that the learning curve is significantly shorter for Godot. It makes it very easy just to learn it very quickly, so you can actually get into the game development part. And also, GDScript as a language is very similar to Python, so it's a lot easier to manipulate.
And also Godot is completely free. There are a few things like from Unity that are stuck behind a paywall. So
Yeah. And so we thought about using Unity, but at the start we did consider like all of these different options. But as for Godot is free, but another thing is it's very compatible with like 2D spriting rather than like Unreal Engine's like 3D ish. Like always see it like using 3D models and Unity. We thought about, but then we just went with Godot because I had previous experience with it, and I could just teach them like bits of how to use it as well.
Also, there are other games on the Psyche Capstone game portal, and the ones that had Unity, we noticed either didn't full screen well or just didn't seem to run as well as some of the other ones that also use Godot. So we decided to just stick with this, just play it safe.
I wanted to ask more about the beta testing that you guys did, not just assessing difficulty, but other aspects of your game. How you approach that kind of feedback? If you use that at all to make changes.
yeah, for sure. So we definitely did make changes after it. So essentially what I did, I actually reached out to my old elementary school. It was kind of like, all right, I'm looking for, around third, fourth graders to test this. And so I had made a Google form previously that kind of just like, how long did it take you? What grade are you in? How hard was it? What was your favorite part about that? And like that sort of thing. And so we were aiming for a sort of like around 10 minutes. And so that was definitely one of the things I noticed was, again, with the third graders, they did take a really long time to complete it. But then the fourth graders actually started speed running the game. So that was like, kind of a really big difference, which was funny. But yeah, no, one of the things that we did change was on the third level of the debris dodging. That was super hard for a lot of people, so we had to change that. Just got rid of a few of the debris bits and like that sort of thing.
After HRSAT testing, after we did all the changes, I did another round of testing with people from my own like family members that are like younger from like elementary to middle school age, and we just have them do similar tests and with additional like changes, like we add a few extra like updates to art and stuff like that before going into that, and I'm not sure what really big change from that. But I think from that we pretty much had our final version of the game, and we more or less just fixed bugs from then on out. And it was a pretty like satisfactory for us. Like we saw it's pretty in the right spot that we liked.
One last question. So, given that this is like well partly education game, I'm wondering if you had a specific message or like information or fact that you wanted to get across, or if this was more of a introductory.
Yeah, so we really wanted to focus on the mission as a whole. Like a lot of the other games that are on the Capstone portal, which if you go there, you can see the other games. And so they really honed in on one specific part of the game. For example, like debris dodging, you think of space, you're always thinking like, oh, the asteroid belt and that sort of thing. And so we did want to give, people like that big general look over the whole mission.
Yeah, I think on top of that, because we had separated them into stages and mini games, just kind of each mini game offers its own kind of educational aspect. So there's not really one thing that we want to hammer down on, but just kind of building kind of that curiosity.